Hi everyone! In this video, we will understand and interpret critical values. Michael, a hospital manager, suspects the proportion of no-show appointments is different from the reported 30%. After analyzing recent data, he calculates a test statistic of -1.50. With critical values of -1.96 and 1.96, does he have enough evidence to reject the null hypothesis? Speaking of null hypothesis, let's go ahead and write the null hypothesis and the alternative hypothesis to help us make the decisions for the hypothesis test. We are talking about a proportion. This means that our two hypotheses will have a p here for proportion instead of a mu for average. So our alternative hypothesis will have a less than, greater than, or not equal to. Let's go look at what was told to us in the first sentence. He is suspecting that the proportion of no-shows is different from the reported 30%. To be different, you can be less than or greater than to be different. This means that it is not equal to 30%, and let's go ahead and change that to a decimal of 0.3. The null hypothesis needs an equal sign, and it doesn't state anything about being less than or equal or greater than or equal. So we are taking the accepted norm as being 30%, so 0.3 is the original claim. And let's go ahead and draw our bell curve so that we can look for what we're discussing with a hypothesis test that is not equal to. Because not equal to or is different can happen in both low and high. We are discussing two tails here. And that makes sense because we were given two critical values. One is 1.96 standard deviations from the mean below. So we're going to have 1, 2, not quite 2. So here's our critical value right here, which makes our rejection region a little bigger than what my circle was originally. And this critical value is at -1.96 standard deviations below. And our other is 1.96 in the positive direction. So we have 1 standard deviation, 2 standard deviations. Again, my critical value, I didn't circle quite big enough. 1.96 isn't quite 2, so 1.96, making our significance level over here, our rejection region. And so now let's look at our test statistic of -1.5. -1.5 is 1.5 standard deviations below the mean. So here's 1 standard deviation, and here's a half standard deviation. So our test statistic, or our t-value, let's write t-value here, is -1.50. That means it is not falling outside of our fail to reject zone, meaning it's falling enough in the norm that it is not in this rejection region, this cutoff, this line that says it's too far gone. So is there enough evidence to reject the null? No, it's falling in the fail to reject zone. So we do not have sufficient evidence. So we don't have enough information or evidence to say that the proportion of no-show appointments is different from the 30% of the accepted norm. And so we've answered our final question of if we have enough evidence to reject it. We don't, so now we're all done.